Hey everybody, welcome back. We're just going to finish up section 3.3 here. In this last little section, all we're going to do is use the slope of a line to determine whether two lines are parallel, perpendicular, or neither. And here we have a graph of two lines that are intersecting at a right angle. And you probably already know that two lines that intersect at right angles are called perpendicular lines. Now notice the slopes of these two lines. This line that's going uphill to the right has a slope of positive 2. And remember, slope is rise over run. So you can look at this line and tell every time it rises 2, it runs 1, 2, 1, 2, 1. So this line has a slope of positive 2. And this line has a slope of negative 1/2. In other words, every time the line goes down 1 unit, it goes across 2. Down 1, right 2, down 1, right 2. So this line has a slope of negative 1/2. Notice the relationship between these two slopes. One's positive and one's negative, so they are opposite signs. And also, one is 2 over 1 and the other one is 1 over 2. So not only are they opposite signs, but they are also reciprocals. And so with the exception of horizontal and vertical lines, we can say that if two lines are perpendicular, then their slopes must be opposite reciprocals. If two lines are perpendicular, their slopes must be opposite reciprocals. Now let's look at parallel lines. Two lines that never intersect are called parallel. And if they're never going to intersect, that must mean that they are slanted the same amount, because if one was slanted more than the other, they would cross at some point. So these two lines that are never going to meet are going to have the same slant or the same slope. If two lines are parallel, their slopes must be equal to each other. Now, knowing that, we can look at the equations of two different lines and use their slopes to decide whether the lines are going to be parallel, perpendicular, or neither when we graph them. So let's start off here with x plus 3y equals 5. So in order to see this line's slope, what we'll have to do is get it into slope-intercept form. We will subtract x from both sides, and that will leave us with 3y equals negative x plus 5. And now we need to eliminate this coefficient, so we'll divide each side by 3. That means we'll divide each term by 3. And that's going to leave us with y equals negative 1/3 x plus 5/3. Now the slope of this line is the coefficient of the x term. Remember, the slope is always the coefficient of the x term. So the slope here is negative 1/3. And now let's look at our second line. So again, we need to put it in slope-intercept form. So we're going to add 3x to both sides. And that's going to give us y equals 3x plus 3. So the slope of our first line is negative 1/3, and the slope of our second line is 3. They are opposite signs, and they are reciprocals, and therefore these two lines are going to be perpendicular to each other. Now let's look at part B. So here our equations are 4x minus y equals 4, and 8x minus 2y equals negative 12. And again, in order to know whether the graphs are going to be parallel, perpendicular, or neither, we're going to need to put the equations into slope-intercept form. So that means we need to isolate the y term. So I'm going to subtract 4x from both sides here, and that's going to leave us with negative y equals negative 4x plus 4. And now I really need to eliminate this negative, so I'm going to divide both sides by negative 1, and that's going to leave us with y equals 4x minus 4. So the slope of this first line is 4. And let's do the same thing with our second equation. So we will move the x term to the right side. That leaves us with negative 2y equals negative 8x minus 12. And again, we need to isolate the y, so we need to eliminate this negative 2 coefficient. So we'll divide both sides by negative 2, and that will leave us with y equals positive 4x plus 6. So the slope of our first line is 4, and the slope of our second line is 4. And since the two slopes are equal to each other, we know that these two lines are going to be parallel to each other. Now let's look at part C. So again, we have lines in standard form. We need to put them in slope-intercept form. So I'll move the 4x to the right side of the equation and divide through by 3 to isolate the y. And that's going to leave us with y equals negative 4/3 x plus 2. Do the same thing to the second equation, so we'll move the 2x to the right side of the equal mark, divide through by negative 1, and that leaves us with y equals 2x minus 5. So now the slope of the first line was negative 4/3 and the slope of the second line was 2. These are opposite in sign, but they are not reciprocals. So these lines are going to be neither perpendicular nor parallel. And on part D, we have 5x minus y equals 1 and x minus 5y equals negative 10. So let's put each of these in slope-intercept form. We'll move the 5x to the right side of the equal mark, divide through by negative 1, and that leaves us with y equals 5x minus 1. So the slope of this first line is 5. And for the second line, move the x to the right side, divide through by negative 5, and that leaves us with y equals 1/5 x minus 2. So the slope of this second line is 1/5. So we had a slope of 5 on the first line, slope of 1/5 on the second line. These two slopes are reciprocals, but they are not opposite in sign. So you would see when you graph them that both lines would slant uphill to the right, not by the same amount, of course, but they're both slanting uphill to the right, so they can't possibly be perpendicular. So again, these two lines are neither perpendicular nor parallel. And that's it for section 3.3. And I hope this was helpful to you. See you in the next section.